How do we estimate an expected value from a sample of the corresponding distribution?
Consider a random variable, x, sampled from this PDF. Remember that the expected value of a function of x, g of x, is given by this integral, the integral between minus infinity and infinity of the PDF times g of x. Assume that we're given a sample with m values of the random variable. We'll assume further that the samples are independent. We can compute the sample average of g, and this is simply the average of the values of g evaluated at the values of the sample. So this we'll call sample average. And this quantity is the expected value. Let's see how these two quantities, the expected value and the sample average, are related. The sample average will also be a random variable because it's just a sum over random values. And if we take its expectation, what we get is that the expected value of the sample average of g is equal to the expected value of g. This property says that the sample average is an unbiased estimator of the expected value. Second interesting property is the behavior of the sample average when the size of the sample goes to infinity. By the strong law of large numbers, this also converges to the expected value of g. Finally, we'll enunciate an important theorem, which is the central limit theorem, which relies on the fact that the values in the sample are independent of each other. The central limit theorem tells us that asymptotically, the sample average goes, as m goes to infinity, as a normal distribution centered at the expected value and whose standard deviation is 1 over the square root of the sample size times the standard deviation of g of x.